Okay, moving into equations of lines in 3-space. So what's our goal for today? You're going to extend your knowledge of vector, parametric, and symmetric form of vector equations from 2-space. So that's what we were doing previous to the matrices lesson. And we're going to move to 3-space, and we're going to develop associated formulas or equations. So I want you to be able to basically do what you're able to do before in 2-space, but now be able to do it in 3-space. So how does it differ? So if I create Cartesian plane, again, every textbook seems to want to draw it differently. So if I have my Cartesian plane, what do we need in order to have the equation of a line? So what is needed for equation of a line? And if you're reading this, you're thinking, well, he's claiming it's very, very similar. I'm extending my knowledge from 2-space, so it should be very similar. And you'd be absolutely correct. You need a point, and you need, before we said slope, but it's actually a direction vector. Those are the two things we need. So how different is it when we talk about 3-space? Well, not a whole lot, except for the sense that our vector now may look like this, okay, which is actually this direction, and here, and then up here. So it actually comes off the page. So in this case, this might be, let's say, 1, 2, 3 on the x-axis. Oops, I guess it would go this way before going up. So let's go 1, 2, 3 on the z, and maybe 5 on the y. So our direction vector now has 3 components, is basically what I'm getting at here. Oops, 3, 5, 3. Okay. And what would a coordinate look like in 3-space? Well, it could be point P, which is located at, that looks like -1. Let's say 0, it's on the y-axis. And let's say 8 on the z. So if that's the case, if those are the only minor changes, is that we've added a z coordinate, it would lead you to believe that the only change now with our algebraic form, x, y, now has a, or sorry, our vector form now has a z component, which would mean that we would have our point P, all right, which would be A, B, and C, plus our direction vector, which would now be D1, D2, and D3. So it would have 3 components. So there we go. So there's our vector equation. Parametric of a line in 3-space. X would equal A plus TD1. Y would equal B plus TD2. And Z would equal C plus TD3. And symmetric form would be x minus a over d1 would equal y minus b over d2 and z minus c over d3. So there you go. So we're just adding our third coordinate form here. So we just have that extra value kicked in here. We have the extra equation and the extra fraction in the parametric and symmetric forms. And that's it. That's the only difference. So any catches? One in the last example, but for the rest of it, it rolls pretty quick. So a line passes through that point and has a direction vector, 1, 2, -1. Determine the equation of a line in vector, parametric, and symmetric form. So it's not uncommon. I want all 3 forms. And like I said before, it's necessary that you're fluent moving from one form to the other. Okay, you need to be able to go back and forth very quickly. We have all the information. We have the point, we have the direction vector, so we go right to final answer. So let's start with, I always find the vector one easiest, -3, 5, 2, so that comes from the point, plus the direction vector, 1, 2, -1. All right, and that's it. So it's almost like going back to scratch again. So if it feels like we're getting later in it, the unit, and it's getting easier, well, we're really just rehashing or going over previously known information. So it should be getting easier, assuming you've done all the homework and kept up with the note. So now taking the x values, x is equal to -3 plus t, y is equal to 5 plus 2t, and z is equal to 2 minus t. And finally, symmetric form, x plus 3, and again, I'll keep it over 1 just to emphasize it. It's not necessary. And if the textbook gives you a question without a fraction, you need to be aware or know that it's over 1 so that you don't forget about that direction vector coordinate. So there you go. There are the 3 forms from the given information. So pure vanilla. Determine the vector equation of a line passing through the points A and B. This question, it sometimes turns out to be a hard question on the test because people just treat this as a coordinate and this is the direction vector. I really don't know the justification. It's almost like student brains kind of lock all of a sudden and you spin out of control into a fiery crash or some form of Warren driving antic there. But anyway, you need to make sure you get a direction vector out of it, and your direction vector is just going to be the vector AB. So point B minus point A. So 9, 2, and 0 minus 1, negative 3, and 2. So gives me a vector of 8. 2 plus 3, sometimes it could be 5, and negative 2. So there's my direction vector. I only want a vector equation. So the vector equation will be x, y, and z. And again, it's you know, you're sitting there right now looking at this thinking this is ridiculous that I did an example like this. However, I can't stress enough, I've seen enough tests where, like I said, student lock happens or brain lock happens and you get confused between points and vectors. So the only reason I put that example in there is to emphasize that exact point. So keep that in mind when you're working your way through. Develop a symmetric equation that's parallel to this line, and the reason it's not in properly is because the Smartboard software doesn't allow me to write that in or type that in. So there's the line passing through that point P. So it's got to be parallel. So this is the easier one. Parallel means that the direction vector from the first line given is going to be equal to the direction vector for the second or new line, which means that we need to be able to pull the direction vector out of that first equation. And the whole trick here, and you see how it's very, very tricky, the t value is always with the direction vector value. So I've mixed up the t's. So it makes it extremely hard. So that's like a level 10 out of 10 question for difficulty. So keep that in mind. So anyway, for those that don't have me as a teacher, actually, I'm being sarcastic, extremely facetious. But anyway, so there you go. So there's the direction vector. They want a symmetric equation. So the symmetric equation, some people are going to be able to go to the symmetric equation right away and tell me that it's x minus 3 over 3 equals y plus 5 over 1 and z minus 1 over 1. If you need to first come up with a parametric or a vector equation first before getting there, that's not a big deal. But for people that can jump to that final line, there is no really intermediate steps for me. You'd get full marks because to me you should be able to come up with all 3 of those forms of equations with that given information and jump to a final step. All right. Determine the vector equation of a line that passes through that point and is perpendicular to, and there is a bit of a typo here, there should be a z there, perpendicular to those 2 lines, and I did it twice. At least I'm consistent. All right, so the question then becomes, how do you find the solution to this question? And this should be all right for time here. So we know we have a point already, so that's the easy part. The point's taken care of. We need a direction vector, because remember we need a point, which I just said we had, and a direction vector. So what is our direction vector? It's right there. It is perpendicular to the lines. So how do we find a direction vector or a line perpendicular to 2 other lines? And I hope people are screaming out the answer that a direction vector, if it's perpendicular to 2 other lines, those other 2 lines have direction vectors. So to make sure that my new line is perpendicular to those two lines. Then I simply find the cross product of those two direction vectors, create a new direction vector that's perpendicular to both. So here comes back the cross product. So our first direction vector was 2, 5, 1, and the cross product is no longer a skill that it's like adding now. You need to know how to do it, and you need to know how to do it on a test quickly and efficiently. All right, so there we are. So 2, 5, 1, 2, 5, 1, 3, 2, negative 3, 3, 2, negative 3. Cross that and that out. So I would have negative 15 take away 2 is negative 17. I would have 3 plus 6 should be a 9, and 4 take away 15 should be negative 11. So there's my direction vector. So now I have a direction vector for my new line. They want the vector equation. Please take note on a test, goes to communication. Are you reading the question? Can you give it to me in the right form? Because that is what I'm looking for in terms of the communication. So the point was given originally as 5, 2, and 8. The direction vector, and you'll notice that, and it hasn't come up before, now I have multiple lines. T is already in use, S is already in use, so I'm going to have to pick a different value to multiply my direction vector by. I'll pick M because it's good. No, I just pick it, it doesn't really matter. 7, negative 17, 9, negative 11. And so there you go. That is your final answer. So what is the trick, or what was the hard part to this question? Right here. So now you need to start making sure you bring back skills like dot product and cross product, because they're going to become more and more important as we move through. And here is the assigned homework. And I'm just going to use the magic pen here a little bit more. There's the homework. If you have any questions, you have any concerns, something's not working out right, please make sure you write it down, and you can talk to me when you have the opportunity. So good luck.